Write the topic Faraday's law of electrolysis. Faraday's law of electrolysis. So first of all, I'm going to write the first law of Faraday's. First law of Faraday. So first I'm going to write and then I will explain from very basic. It is a very easy law to understand and we will get a mathematical equation that is called formula and we will do some numerical on this law. So this law is basically according to this law. Write with me, please. According to this law, the mass of a substance is deposited or liberated wait a minute. The mass of a substance is deposited or the mass of gas liberated at a particular anode at a particular cathode. Sorry, electrode, not anode, not cathode. We are talking about at a particular electrode is directly proportional to the amount of charge passing through solution. Passing through solution. Please write this, then I will explain it what it is exactly. What is this mass of substance deposited or the mass of gas liberated at a particular electrode, and we know that electrode is of two types, anode and cathode. First write it and then let me know. Done. Samia, Madiha, and Ayman, let me know when you are done with this, one by one.
So done.
Very good, Samia. Okay. Now see, we have an electrolytic cell. And what is electrolytic cell? There is two container. First container 1, container 2. and this is like that. Now wait a minute. We will take in a single container. It will be very helpful to understand. Now we have a container in which there are two electrodes and it is connected like this. And you know that the bigger one is positive terminal of the battery or cell, or the smaller one is negative terminal of the battery of the cell. That's why it is negative, and we call negative electrode that is cathode, and it is connected with positive terminal of the battery. So it is positive electrode and it is known as anode. So everyone understand what is cathode and what is anode. The electrode which is positive is anode and negative is cathode. Now see, there is a solution of NaCl in molten state. You can call it for now NaCl solution in molten state. So when NaCl will be in solution, it will be dissociated into ions Na plus Cl minus. Yes or no? Since it is in aqueous or you can call it molten state, it will be in the state of Na plus and Cl minus. Is that clear? Ayman, Samia, Madiha?
Yes, sir.
Yes, sir.
If you have any doubt, please let me know. Okay. Now see, you can see that this is positive charge and this is negative charge. So this will attract here and this will attract negative, because positive and negative charge attract each other. So it is very easy to understand. Na plus will go to cathode and it will go, Na plus will go and stick to this. That is basically Na is deposited on cathode. So we are talking about into this law, the mass of substances is deposited. Since mass of substances deposited whenever it will be in solid state, the mass of substances deposited on a particular electrode. Now see the next definition, the mass of gas liberated. Since chlorine is a gas, since chlorine is a non-metal, chlorine will go to positively charged and it will lose some of its one electron and it will be converted into half Cl2 and this. How it basically in this container there will be oxidation as well as reduction. Na plus will go to negatively charged electrode cathode and it has very negative charge. It has electrons, more electrons. So it will gain one electron and it will be converted into Na solid. So this sodium is deposited on cathode. Okay. And when we talk about Cl minus is already electron rich, negative charge, and it is going on anode, which is positively charged. So Cl minus will donate one of its electron and convert into Cl2, because chlorine exists in diatomic form. And to balance it, I am going to multiply it by like this. So the next term, the mass of gas liberated at particular electrode. That means whether it is a solid or gas, the mass of this will be directly proportional to the amount of charge passing through the solution. Amount of charge passing through the solution. If you are going to increase the amount of charge passing through this solution, deposited on cathode or anode will be more and more. Are you getting my point? Ayman, Samia and Madiha?
Yes.
Very good. So please write it. Then I'm going to, okay. You already, you all have already done with this. Okay. Now I'm going to derive a formula for this. Now you can see mass is directly proportional to the charge. This M is mass of a substance deposited or gas of mass of a gas liberated at a particular electrode, directly proportional to the charge. Whatever is the charge is passing through that solution, mass will be directly proportional to that. And to remove this proportionality sign, I am going to use a constant, that is Z. And what is this Z? Z is basically equivalence. This is constant of proportionality constant and known as electrochemical equivalence. This is electrochemical equivalence. Just write it, electrochemical equivalent. Now we have a formula for Z, that is Z equals to F upon E. F upon E. Wait a minute. I'm going. Yes. E upon F. Z is equal to basically E upon F. E is equivalent mass. E is equivalent weight or mass. And F is basically Faraday's constant. F is Faraday's constant, which has a value approximately 96,000, we take 96,500 Coulomb. I'm going to explain each term one by one. Please write this up to this, then let me know. M directly proportional to Q. M is equal to Z into Q. Z is electrochemical equivalent, and we have a formula for Z. Electrochemical equivalent will be equal to equivalent weight or mass upon Faraday's constant, which has a value 96,500 Coulomb. Please write it. We can easily modify this formula. M is equal to E upon F into Q. Let me know when you are done with this, everyone. Sami, are you done with this, Maria?
Yes, sir.
Okay, Ayman. Okay. Now see, you also know that from physics, electric current, I is equal to Q by T. So Q can be written as I into T. So I'm going to again modify this formula. M is mass of substance deposited or mass of gas liberated. E upon F into I into T. Please write this. So I want to ask some questions. F is given, F is constant, and we know the value of F, that is 96,500 Coulomb. I is current. We know what is current. Time is time. What about this E? Does anyone know about E? That is equivalent weight or equivalent mass. In solution chapter, we already covered equivalent weight or equivalent mass. Just let me know if you don't remember it. And I mean, do you know what is equivalent weight? Because this term is already in class 11. That's why I'm asking.
No, sir, I don't remember.
Okay, no problem. Anyone? Samia, Madhya? If you don't know Samia, Madhya, please let me know so that I will start explaining. No, sir. You don't know. Very bad. Okay. See, equivalent weight or equivalent mass has a formula that is molar mass upon X. And X is basically valency factor. And sometime in some books, it is written as N factor. X is N factor or valency factor. So my first question is that, does anyone have problem in calculating molar mass? Can can you calculate molar mass of any compound?
Yes, sir.
If you don't know, please let me know. Okay. So molar mass we can easily calculate. What is molar mass? Molar mass is basically sum of all atomic masses. Sum of all atomic masses in a compound. In a compound. Like if we have to calculate molar mass of H2SO4. So we know the atomic mass of hydrogen is 1, and since 2 hydrogen is there, so I'm going to multiply it by 2 plus sulfur is 1. What is the mass of sulfur? 32. So 1 into 32 plus oxygen is 4. So 4, and 1 oxygen has atomic mass 16. So if you are going to add it, you will get 98 gram. So this is molar mass, and we can easily calculate the molar mass of any compound. And generally, if the compound in which the atoms are present between 1 to 20 atomic number, then atomic mass will not be given in the question, and it may be given or not given. But after 20, after atomic number 20, if any compound, like if you have CuCl2 or anything else, the atom which is having atomic number more than 20, then in the question it will be given. Is that clear? So it is very easy to calculate molar mass. Sum of individual atomic masses is equal to molar mass. Is that clear? Ayman?
Yes, sir. Yes, sir.
Yes.
Now, so please write it, and then I'm going to discuss what is X, and this X is very important. Let me know when you are done with this. Done. Everyone done with this?
Yes, sir.
Okay. Now see what is x, how we are going to calculate x. See, x is very easy. I have already taught you this in solution chapter. There was a term normality in that. So see how we are going to tackle x. So x is, if that is an acid, so x will be equal to number of H plus given. So if the compound is acid, so how we are going to find the value of x? That will be equal to number of H plus given. That means basically if you have H2SO4, Aman, can you tell me how many H plus it will give you? H2SO4, how many H plus can give? If you are going to dissociate it and balance it, you will get H plus and SO4 minus 2. And if you are going to balance it, how many H plus it gives? 2. You just need to dissociate it and then balance it, then see how many H plus it can give. 2H plus,
Okay, sir.
that means X for H2SO4, valency factor for H2SO4 will be equal to 2. So if you are going to calculate equivalent weight of H2SO4, it will be equal to molar mass upon X. And we have already calculated molar mass 98 upon X, we just calculated 2. So equivalent weight of H2SO4 will be equal to 49. Is there any doubt in this?
No, sir.
Now, so can you tell me how many H plus HCl can give? How many H plus can HCl can give? I'm asking from you because all the students from this batch
Sir,
already
one.
covered in solution. 1 H plus, because if you are going to dissociate it, H plus and Cl minus, and it is balanced, since it is giving only 1 H plus, so X will be equal to 1. Okay, so if you are going to calculate equivalent weight for this, so it is very easy. Equivalent weight will be equal to molar mass of this upon X. Molar mass of this chlorine 35.5 and hydrogen 1, that will make it 36.5 upon 1. So this is equivalent weight of HCl. So this is how we are going to calculate equivalent weight, which is where the compound is acid. So here how we going to calculate X? That is, if the compound is base, then X will be equal to number of H minus given. Fx is equal to number of, am I to all of you clearly? Is my voice lagging? Wait a minute. If my voice is lagging, please let me know. Ayman, Madiha.
It's okay now, sir.
Okay. Okay. Whenever it lags, please let me know. I'll change the network. X is equal to number of OH minus given. So if we have an OH, can anyone tell me how many OH minus it will give?
One.
I'm going to switch off my video so that it will be more frequent. So if you are going to calculate equivalent weight of NaOH, molar mass, and since only one OH minus is given, so it is divided by X equal to. Can anyone tell me how many, what is the value of X for MgOH whole twice? Please let me know how many, what is the value of X? Very good. Ayman, Can you tell me? Samia, what is the value of X for MgOH whole twice? So for base, X is equal to number of OH minus given. So MgOH whole twice will give 2OH minus. So basically equivalent will be equal to whatever is the molar mass of MgOH whole twice divided by 2. Is that clear to everyone?
Yes, sir.
So this is very easy. Calculate X, that means valency factor. Now, if the compound is solid, take NaCl, CuCl2, like this PbCl2, etc. Then what is the value of X? In this case, X is equal to either we take positive charge, total positive charge, or we take total negative charge. Total positive charge or total negative charge. Both will be equal because it is solid. So NaCl, you can see NaCl. If you are going to dissociate it, convert it into Na plus Cl minus. Both the charges will be equal, and we just need to take magnitude, not the sign. So X for NaCl 1. Because if it is also 1 and negative it is also 1, but we need to take only the magnitude, not like one minus we don't need to take. If to see what is the value for CuCl2, you can see it is Cu plus 2 and it is 2Cl. So what is the total positive? You can see total positive charge is plus 2. And what is the total charge? You can see on one chlorine negative 1 minus 1. So in 2 chlorine it will be minus 2. So X for this will be equal to 2. So it's very easy. Please write it all. Then we will come again on the formula. M is equal to E by F into I into T. F is Faraday's constant.
Done, sir.
Done, everyone.
No, sir.
Ayman. Okay. Equivalent weight formula is very important in this chapter.
Yes, sir. Done.
Very good. So we had a formula that is M equals to Z into ZIT. M equals to E by F into I into T. Or we can write also M is equal M is equal to Z into Q, and we can also write E by F into Q is equivalent weight, and I have already written the formula. E is equal to molecular mass upon X, and I told you how to calculate X. X is basically, you can see change in oxidation state also, you can see change in oxidation state. Like if there is Cu plus 2 and it gains 2 electrons and converted into Cu solid. So you can see from plus 2 to 0. So the change will be 2. So X, value of X will be equal to 2. You can calculate it like this also. So I'm going to give you a question, very easy question. Find the amount of copper deposited. Find the amount of copper deposited when 5 ampere current is used for 1 hour. It is simple question. Just go through it and let me know. 1 hour. 2 electrolyte. CuSO4. Also, it is given that CuSO4 solute. Also, it is given that weight of copper is 65 gram, and 1 Faraday's value is given as 96,500. So give it a try and let me know if you are unable to solve it. Now I will explain. you don't get it, let me know. I'll explain.
So is the answer 5.9?
5.8.
5.9.
Okay, but 5.8 gram, 9 gram, that is almost equal. Ayman, do you have any doubt in this?
So I'm trying
See,
to
Ayman.
solve it. No doubt yet, but okay.
Okay. Samia, then I'm waiting for your answer. Oh, wait. Samia, what about you? Let me know when you get your answer.
Sir, I'm getting 14.9.
14.9. Now see, no problem at all. The answer is basically 5.8 gram. Now see, we need to calculate the mass of Now you can see that we need to calculate the mass of copper deposited when 5 ampere current is used for 1 hour to electrolyte CuSO4. So you know that Cu plus 2 it will be, and when it will be deposited, it will be converting into Cu solid. Yes or no? Ayman, Madhya, we don't need to concentrate on the second part because the question didn't ask anything about SO4. Ayman, Madhya, sir, no, okay. Ayman, did you get it? Ayman, please reply. Okay, now see, so we need to calculate mass deposited of copper. So M is equal to E upon F into I into T. I into T. What is the equivalent weight? Can anyone tell me? Equivalent weight will be equal to molar mass upon X. And we are talking about only copper. So we take mass of copper upon X. X is, I told you, change in oxidation state divided by 2. So we got the value of E as 63.5 divided by 2. Again, what is the value of F? F will be equal to 96,500 into current. Current is 5 and it is 1 hour. We need to convert it into second. So it will be 60 into 60. Now just convert it and you will just solve it. You will get your answer. 63.5 upon 2 into 96,500 into 5 into 66, 60 into 60, that will be equal to 3600. Now I'm just going to cancel it. 20 will be cancelled by 2 zeros. Now I'm going to solve it. This will be equals to 11,430 divided by 2 into 965. We left 965. That will be equal to 1930, which will be cancelled by each other, and there will be 1143 divided by 193. So when we divide 1143 divided by 193, we get, yes, that is 5.9 gram. This is your answer. Ayman, please let me know where you had mistaken.
Sir, I think somewhere in the calculation, because my method was
So basically we had okay. So basically we have two methods to solve this. The first method is by applying the formula, and the second method will be basically a short trick to solve it in a short time, very short duration of time. Please write it and let me know. Then I'm going to use another formula. Not formula, it will be a trick. Please let me know when you are done with this. Waiting for long. Samia. Please do it and let me know.
yes, sir, done.
I just solved it. Okay. So see, I'm going to tell you another formula or another trick for it. Do you know how does the value come 96,500 coulomb? How does it come? You know what? This is basically the value of 1 mole electron. 1 mole electron. Basically, the charge on 1 mole electron is equal to, I'm going to write charge on 1 mole electron. 1 mole electron. That means you know that 1 electron has a charge that is 1.6 into 10 raised to the power minus 19 coulomb. And we are talking about 1 mole, and we know that how many particles are there in 1 mole? 6.022 into 10 raised to the power 23. So if you are going to solve it, it is approximately, it will come out to be 96,487 coulomb. And for calculation, we take 96,500 coulomb. Got it? This is a small point.
Yes, sir.
Nadia, Samia. Now see, I wrote an equation that is Cu plus 2 will be deposited after gaining 2 electrons from cathode, and it will be Cu solid. It will be Cu solid. I am switching off my video because it's hanging. The screen is hanging. Now it will be basically Cu solid. Now from class 11th, you know how to compare the moles. So basically you can see this is what is the coefficient, stoichiometric coefficient of Cu plus 2. Can anyone tell me what is the stoichiometric coefficient of Cu plus 2? 1. Because we see we use the term stoichiometry coefficient in chemistry. This is same as coefficient. So like if I am going to ask you what is the coefficient of x cube, what is the coefficient of x cube? What is the coefficient of x cube? Can anyone tell me what is the coefficient of x cube? Madiha, Ayman, Sami, 1. So in the same way, what is the stoichiometric coefficient of Cu plus 2? 1. What is the stoichiometric coefficient of electron? Ayman, I want the answer from you. What is the stoichiometric? In mathematics, we use a coefficient, and in chemistry, we use a stoichiometric coefficient. So Ayman,
Sir,
can you tell
2.
me what is the stoichiometric coefficient of electron? 2. Very good. So basically, I'm going to write it as 2 mole electron gives us, what is the stoichiometric coefficient of this? 1. Gives us 1 mole copper. This is how we read stoichiometric question in the in reaction. Like if you have CH4 plus O2 will give CO2 plus 2H2. Now I am going to balance it by multiplying it by 2. In mole concept, we need to balance it. It is very important. And in class 11th, first chapter, there is a topic that is stoichiometric and its calculation. So basically, what does it say? First, check it whether this equation is balanced or not. So it is balanced equation: 1 carbon, 1 carbon, total oxygen 2 to the 4, and total oxygen 2 plus 2 4, hydrogen 4, hydrogen 4. That means it is balanced. So how we are going to read it? Stoichiometric coefficient 1. 1 mole of CH4 react with 2 mole of O2 to give 1 mole of CO2 and 2 mole of H2O. How we are going to read it? 1 mole of CH4 reacts with 2 mole of O2 to give 1 mole of CO2 and 2 mole of H2O. In the same way, we are going to solve this. Say 2 mole electron will give 1 mole Cu. 2 mole electron will give 1 mole Cu. And I already told you that 1 mole electron will be equal to 1 Faraday. Yes or no? From this, you can see 1 mole electron is the value of Faraday's constant, 96,500 coulomb. That means 2 mole electron can be written as 2F coulomb will give 1 mole electron, 1 mole copper. Yes or no? Please tell me. And if you don't get it, let me know, please. Ayman, Madiha, Samia. This trick is very important. It is very easy to get the answer in short duration of time. Yes, Ayman.
Yes, sir.
Are you getting it?
Yes, sir.
Sir,
What you just said, Samia?
can you repeat this?
See, Samia, Cu plus 2 There we need to calculate the mass of Cu, and you know that Cu is in CuSO4. That means CuSO4. If you are going to dissociate CuSO4, it will be Cu plus 2. So this will go to one of the electrode, so it will gain 2 electron and it will be converted into copper solid. So we are going to write 2 mole electron will give 1 mole Cu. So 1 mole electron has a value 96,500. That means 1 Faraday. 1 mole electron has a value 1 Faraday. So 2 Faraday will give 1 mole copper. Can anyone tell me what is the mass of 1 mole of copper? This is very easy question. Can anyone tell me what is the mass of copper in 1 mole? Please write it, then I will again explain. There is so many hodgepodge. That's all. Let me know when you are done with this. Are you done with this?
Done, sir.
Thank you. Ayman, are you done with this?
Almost, sir.
Okay. Let me know when you are done with this.
Done, sir.
Very good. So I will again write these points and then I will explain. Nadia, did you get the answer? 1 mole of Cu is equal to how much mass? Samia, if you are done with this, please calculate the mass of 1 mole of Cu.
Sir, it is 63.5.
Done. Very good, Nadia. Only 63.5, not 4. If I give atomic mass of 6. Copper is 63.5.
63.546 actually.
Okay. Okay. Got it. Done. Ayman,
Yes, sir.
now see what I had written is Cu plus 2 electron will give Cu solid. So if you are going to write, you will write 1 mole of Cu plus 2 combined with 2 mole electron, 2 mole electron to give 1 mole copper. Since we don't need this, so we are not going to write this. And we also know that 1 mole electron is equal to 1 Faraday. So 2 mole electron will be equal to 2 Faraday. 2 Faraday will give 1 mole copper. I mean, have you calculated the mass of 1 mole of Cu? See, there is a small formula, number of moles is equal to given mass upon molar mass. What is the number of moles? 1. And molar mass of copper, that is 63.5 upon mass. So mass will be equal to 63.5 gram. So in 1 mole Cu, we got mass of 63.5 gram. And 2F, that means 2 into 96,500 coulomb. From this charge, we got 63.5 gram. So in 1 coulomb, we will get 63.5 upon 2 into 96,500 gram. Yes or no? This is unitary method. But we need to calculate in 5 ampere and time is 1 hour. So if you are going to calculate charge, Q is equal to I into T. Q is equal to I into T. Current is 5 and the time is, we need to calculate it in second. So 60 into 60. So we need to calculate in this charge how many masses will be deposited. So that will be 5 into 60 into 60. In this coulomb of charge, 63.5 upon 2 into 96,500 into 5 into 60 into 60 gram. And when you will solve it, it will be approximately 5.9 gram or 6 gram you can. So this is very easy. We don't need formula for the first law of Faraday's. We can do it by simple unitary method. Nadia got it? Samia, Ayman?
Yes, sir, I got it.
Yes, sir.
Very good. Thank you. Please write it and let me know. Then I will give you another question. Done.
Done, sir.
Let me know when you are done with this. Sorry. Let me know when you are done with this, please.
Yes, sir. Done.
Okay. Maria and Samia, you are also done. Now, I'm going to give you
Yes,
another
sir.
question on this. Thank you. How long should a current of 0.25 ampere be passed through a molten metal state to deposit that much weight of metal, which is equal to its electrochemical equivalence, which is equal to its electrochemical equivalence. So the question is very easy. Please read it carefully. I'm waiting for your answer. We need to calculate the time. Maria,
Yes, sir.
any answer?
No, sir. Can you explain it?
Okay. Okay. See, how long should a current of 0.25 ampere? That means current is given as 0.25 ampere. It is so easy. We pass through a molten metal state to deposit that much weight of metal, which is equal to electrochemical equivalence. That means mass deposited, weight deposited, or mass deposited, these are equal to electrochemical equivalence, and we got a formula M is equal to Z into Q, and these are equal. So it will be cancelled, Madhya and Samia. So this when it will be cancelled, Q will be equal to 1, and you know that Q is equal to I into T. I into T is equal to what? 1. So I is equal to T is equal to 1 upon T. T is equal to 1 upon I. So what we got, it has a value 0.25. If you are going to remove the decimal, you will get 100 in numerator, and the answer is 4 seconds. Yes or no? Madhya,
Yes, sir. Yes, sir.
please write it. So if I'm going to give you question like how much charge is required for reactions, 1 mole Al plus 3 will be converted into aluminum, 1 mole Cu plus 2 will be converted into Cu, 1 mole Na plus is converting into Na, and the last one is fourth one, 1 mole MnO4 minus is converting into Mn plus 2. We need to calculate the charge. Let me know when you are done with this.
Sir, I got the answer.
What is the answer for the first?
It's 3 Faraday.
It's 3 Faraday. That's good. You know that Al plus 3 will gain 3 electron, and it will be converted into A. So 3 Faraday, 3 mole Faraday. Basically, this is 3 mole electron. 3 mole electron will give 1 mole aluminum. 3 mole electron, that means 3 Faraday will give 1 mole aluminum. In the same way, Cu plus 2 will gain 2 electron, and it will be converted into 1 mole copper. So we have two for 2 mole electron will be converted into this. Yes or no? What about this? The fourth one and the first one. First one is basically 1 Faraday will give 1 mole Na. Yes or no? Madhya,
Yes, sir.
what about the fourth one, last one?
Sir, it's 5 Faraday.
5 Faraday. How did you calculate? It's +7, it's +2. So MnO4 minus will gain 5 electron to convert into Mn+2. So 5 mole electron, that means 5 Faraday. Very good. Are you done with this? Please do question number 19. Can you do this, Madhya?
Yes, sir. Just a minute.
Madhya?
Yes, sir, I'm doing it.
What is your answer?
No, sir, I'm calculating 1 minute. Sir, is the answer 1?
Yes, it is. Very good.